Hello and welcome to this lesson on using conditional loops in VBA. So the first type of loop we're going to cover in this section are conditional loops. And there are two types of conditional loop, the do while and the do until, which are known as do loops. And these conditional loops, a condition determines the exit point of that loop. Some of the other loops we cover in this course will run a predetermined number of times, or a number of times that Excel will know. In this scenario, we're going to create our own condition for the loop. So it's very important that we check and double check the condition of the loop before we run it. Otherwise, you can find yourself in an infinite loop, a loop that cannot exit, and will just continue until you can break that loop, which can sometimes be done by pressing Control and Enter, or by pressing Escape, but it's quite often the point that you find you can't exit it. So very important to kind of save work as you go, so you have a backup, but even more important, double check your condition before you run a loop. So an example of our do loop here, I'm going to enter 10 numbers from A5, I won't do 10, I'll do 5. 5 numbers from A5 down to A9 there. And what I'm going to do is set up a loop to run through all the numbers in this list, of which there are only 5, and add 1 on top. Now I'm not going to ask it to run 5 times, I'm asking it to perform the loop on every number in the list, so until it runs out of numbers. So there will be a condition to determine the exit point. So let's switch to the editor, and I'm going to insert a new module and a new sub-procedure, which I'll call do loops. And the first one we're going to look at is the do until loop. So just like when we looked at the if then else and the select case statements, these structures are commonly named after their keywords. So this is known as a do until loop, and it is written with the words do until followed by the condition that's going to determine the exit of this loop, which in this scenario is that the value of the active cell is empty, it equals nothing, and then followed with the word loop. And in between them two lines will be the statements to repeat until that condition exits this loop. So we've got a nice repetitive action. And our statements are going to be that the active cell dot value should equal the active cell dot value plus 1. So add 1 on top of the current value in the active cell. And then we're going to move one cell below. So I'm going to offset one cell below. So let's click in cell A5 to make that the active cell and step through our code using F8. So it will come in here and it will do the initial test. So right, is the active cell empty? No, it's not. And I have to do it until the cell is empty. Therefore, it will move into the set of statements, add 1 on top, move 1 cell down, and loop back round. Perform the test, move inside, add 1 on top, move 1 cell down, and loop back round. And it will do this until it runs out of cells. So here it goes. Is it empty? Yes, it is. Exits and continues with any other statements you may have in that procedure. So as you can imagine, loops are huge in VBA code. We will be using them an awful lot. It's one of the primary reasons you will be using macros in the first place, that you have this repetitive procedure. So that is our do until loop. I'm going to change that word until to while. So the other type of do loop is a do while loop. And I can quite easily create the same action here by changing my loop to do while and then saying do while would have said it's not empty. So if I click in cell A5, I could step through this and realise that this achieves the same objective. Now there is a difference between the logic, so it's not always going to be the case that you can pick and choose what one you want out of the two. It may be important that you choose the right one. But quite often, you pick your favourite almost, the one that makes more logical sense to you to do until it's empty or to do while it's not empty. It's worth mentioning that on both these types of loop, you can also position the test element of it after the loop statement as opposed to after do. Now I would say that you're more likely going to come across it, it's very common to see after the word do as opposed to its position now, but it's okay to do this, and what this would ensure is that the statements are actioned at least once before it performs the test. So the way we had it beforehand, it might perform the test and then not even enter the loop, just carry on, it's not relevant. Whereas now, it will perform the actions at least once before looping. So I'm going to move my statement back to the top, and I thought we'd just have one more look at a loop. So I might leave it as a do while, as that's what I have. I'm going to click on cell A5 to put my active cell at the top before I forget that when I test this. And this time I'm going to change the condition to ask it to do it while the active cell dot value is less than or equal to 5. So now I'm expecting it to not do it after row 7. So it will do it to row 7, because I asked it was equal to 5, but not after it. So if we come in, is 3 less than or equal 5? Yes it is. Add 1 on top, move down. Is that? Add 1 on top, move down. Is that? Yes it is equal to 5. So add 1 on top and move down, and then exit. So we're going to see a very strong case for these do loops. We'll be seeing them a lot throughout the rest of this course. For now, it's just a quick example of what these loops can do. And yeah, this is a conditional loop. That condition determines the exit point of that loop, just to make sure we're happy with the structure before we go any further. As mentioned, just to throw it into this lesson again, please check and double check that condition, because if that condition is not accurate, you may find yourself in an infinite loop, and that is worth telling twice. I've done it more than once. It's easy to do, which is why I'm emphasising that point. Something that don't have to worry as much about in some of the other loops you're about to look at. Hello and welcome to this lesson on using the cells object in our conditional loops. So what I've got on screen is I have the procedure from the previous lesson, where we have a do loop that is looping through a certain number of cells and is just incrementing 1 to the current value in that cell. And on the previous lesson we used the active cell reference to a cell, and we used the offset property to move to one cell below. We've got dot select to actually move to that cell. Now a more effective way, rather than selecting each cell, is to use the cells object and just to increment, to kind of reference each cell rather than to move to them. So what we can look at doing instead is to create a variable to store the row number, and then to increment that row number each time, so that we can reference each one without actually moving to it. So if we were doing this to say 60,000, 600,000 rows, this would be an incredible difference in kind of the speed that this macro is going to run. Whereas the way we have it at the moment, for 5, 10 cells, you're not going to notice any difference. But if this spreadsheet was to get larger, you will certainly notice the the speed of this macro dramatically decrease as we're asking it to select every single cell in turn. So, first thing we're going to do here is, within the procedure, I'm going to declare a variable that's job is going to be to store the row number. So I'm going to call it row num, and I'm going to use it as the data type of long, which can handle large integer numbers. And then I'm going to assign the row number to that variable. So I'm going to say row num equals active cell dot row. So row there is a property of the active cell, so that when I start with this macro, and if I have cell A5 selected, for example, it will be assigned number 5. So if I demonstrate that now briefly, if I press my F8 key, I can see at the bottom the row number variable that get declared, and as I move past that initial initialization statement, I can see it take the number 5. So let's just reset that. That's working fine. And now in the loop, instead of referencing the active cell, which would still work at this point, I'm going to reference cells, opening bracket. So it'll prompt us for the row's index number, which I'm going to say is a row num, the variable that we are using to store the row number, comma, the column index, which is actually optional. The square bracket is saying it's optional, so I could omit that at this point because I'm dealing with this one column. But I'm going to type 1 in there because I believe that makes our coding more descriptive if we answer a lot of these questions rather than leave them empty. And I'm going to put a closing bracket. So at the moment that's row 5, column 1. But, that will change itself as this macro moves through. So do until the cell we're referencing is empty. Now instead of active cell here, I need to change that to that again. So let's take a copy of what I've got there, that cells object, so that I reference the right place. Row num, comma 1. And I'll paste it over active cell here as well. And then instead of this line here with offset, I'm going to put row num equals row num plus 1. So what we've got now, I can make sure I'm in cell A5 in the background there. As I press F8, and it starts from row 5, say do until the cell's object is empty. Well, at the moment it's not empty. It will move in, add 1 on top, I can see in the background, and add 1 to the variable. So I can see at the bottom, next time round it will reference row 6. So as it loops round, it references row 6. Notice in the background it's not gone to row 6, but we are referring to it because it's a 6th row, first column now. In it goes, adds 1 on top, I can see that in the background, and around it goes again, constantly adding 1 on top, but it's not actually moving to those cells. We're just incrementing our variable and referencing it using the cells object that I don't know if you remember, but I mentioned earlier on in the video about different techniques for referencing cells, sheets and books, that the cells object was going to be a big deal later in the course, but it didn't really make too much sense earlier maybe. And this is what I was waiting for. It is the most efficient way of referencing a cell when going through a loop. Not just a do loop, a conditional loop like this, but also some of the loops we'll see shortly, some of our counter loops, our for next loops. The ability to use cells and store a variable in there, which we could be doing for the column index as well, is a far more effective approach than active cell and offset. That's not to say that active cell and offset are wrong. They're typically known to be easier to write, so unless your code warrants it, maybe you want to stick with them. It'll probably be easier for people to read and for yourself to use. But if we're dealing with large scale stuff, cells is your winner. Hello and welcome to this lesson where we have a closer look at the do loops and our conditional loops with a practical example of adding or updating to an inventory sheet. So on screen at the moment I have a small inventory sheet. Choose an example with an ID, name, current stock level and a date last updated for a list of stock. And on another sheet called update, I just have a stock item, oranges 1005, which is currently on the other stock, which I'm going to use as an example, among others, of updating this inventory sheet with. Now, in my editor, if I switch to the editor, I've just used comments as a quick kind of brainstorming exercise to list some of the things we're going to need to do in this example. So I've put that I want to store the item ID, name and value in variables. So if I just restore this window for a moment, and I might indeed look at restoring this one as well to try and get a little bit of space on two screens if I can. Yes, I want to store these three cells in variables so that when I switch to this sheet I can easily reference them rather than have to say something along the lines of worksheet, update, range A2.value. Yeah, I want an easy reference. Now we want to use a do loop to search for the item ID. So the first example is this one. But in reality we don't know that. So I want to be able to look down this column looking for the ID. If it finds the ID, I want to add the delivery into the current stock level and put today's date as the date it was last updated. If it cannot find it, what I want to do is add it in as a new entry down the bottom here with today's date, the level and this new entry. A message will be displayed to the user to say that the inventory was added, and then the cells on this update sheet will be cleared because that item has been added. We don't need them there anymore. So that is what we're planning on doing in this practical do loop exercise. So, without further ado, let's get going. And the first thing on our list is to use variables to store the item ID, name and value. So feel free to have a go at this in your own time. Stop the video now. Use this sheet that I've provided to download and have a go. Otherwise, continue watching and we're going to get this job done. So I'm going to declare three variables. One I'm going to call item ID and is going to be storing a long data type. I'm going to have another one which I'm going to call product name, which is going to store data of a string data type, and another one which I'm going to call delivery and is going to be as I'll say an integer. We do not have the warehouse to store more than 32,000 odd, so I'm going to play with the integer value on that one. So hopefully this is a good recap for a lot of the key topics from the course so far, like the use of variables here. Now we need to assign values to them next, and these are just normal variables, they're not object variables, so you don't need the word set. I can just say item ID equals range A2 dot value, and I'm going to take a copy of that line to possibly save me some time. And the second one will be product name, and the last one will be delivery, and the range will be B2, and the last one C2. So as easy as that, we have variables declared and data assigned to them. So I can remove this first job, this first task. First bit, done. So I'm imagining that the button that we're going to be clicking to add this will be on this sheet. So my references to that data are very contextual. I didn't mention a sheet to name because the way I want to set this up is that I know somebody will be on that sheet when they run it, because that's where the button will be. So I can reference it straight through range, our classic absolute reference. But when I look for the ID, next up is to search for the ID, I will need to be on the other sheet. So I'm going to reference that, or I'm going to move to that sheet now with worksheets inventory dot select. Well, let's activate. So I'm on that sheet. Activated. The worksheet's called inventory. Now I want to use a do loop to search, and the plan here is that we're going to use another variable. I'm going to use a variable with a Boolean data type, which has not been mentioned in our tasks here, because we've kind of got three options as we loop through. We're either going to find the item and add the delivery amount on top along with today's date. We're going to realise that we've got to the end and we've not found it and enter it as a new product. Or we haven't found it yet and we're not at the end, so we have to move down a cell to keep looking. So we've kind of got three options there. So we need more than just your standard test. I can't just say do until we get to the bottom, because I've got other things to take into account. So what I want to do is create a Boolean variable, which is one of our true-false variables, and use it as a key as a way of exiting this loop at any given point. So I'm going to declare this variable first of all at the top. I'm going to say dim keep searching equals true. Sorry, not equals true, as Boolean, jumping ahead of myself there, a Boolean data type. And then, as you might have guessed from that last bit, I'm going to say keep searching equals true. So I'm setting a default value to it. Declare a variable that can only handle true false values and initialize it with the value of true. So that then I can set up a do until loop and say to do until keep searching equals false. Do until my keep searching equals false. It currently says true, so it will be moving through this loop. I will need to assign false to the statement as a way of exiting the loop. Next, I'm going to keep them comments kind of in play there, and I'm going to put the word loop. Good practice to put that in so we don't forget. And in between them two statements, I'm going to put the statements that are going to need to be repeated, the actions to repeat. And our first step is to be looking for the search ID. Now, as we look for it, let's pop to inventory at this point, because that's where we would be if this was happening. As we look for it, I want to start from cell A3 and search down each one. Now, as we saw in a previous video, you know, I could use active cell. I could say range A3.select and then say things at active cell and active cell dot offset 1,0. But instead I'm going to use the cells object. I mentioned in the previous video that cells is a far more effective way of looping through and referencing cells. And I'm going to use a row number to reference the row, which I'll just increment each time. So another variable, I'm afraid. This one's going to be dim row num. I do like to call my row numbers row num. as long. This might be a very large inventory sheet. And I'm going to initialize that one, as you do, with the value of 3. Because the first row number to be checking will be 3, the third row. Oops. Okay, now let's get inside this loop and let's start putting in our searching for the ID. Now, to test if it's the ID or not, we are going to tab this in for some good indentation for readability. Let's get rid of that locals window for a moment for a bit more room. And we're going to use an if statement. If cells row num, comma 1, column 1, dot value equals, what did I call it? Item ID, then if there is a match between the value of the current cell and the item ID, then you've found that product. So what do you want to do? Let's put our end if in for good practice in case we forget, and tab in between. Well, if we found it, we want to add the delivery amount on top of it, and we want to put today's date in. So I'm going to say that cells row num, comma, and the stock level is always column 3, dot value equals cells row num, comma 3, dot value plus delivery. So delivery is the variable. Can I get a little bit more from this? Is the variable that is storing this figure here, just to make sure we're happy. So I'm adding that delivery amount on top of the current amount. So if it was apples that was found, the third column, add it on top of that. Okay, and then put in today's date. So cells row num, comma 4. The last updated information's in the fourth column. Dot value equals, I don't know if you remember this from one of our earlier videos, date. A function called date will put in the date from your computer, the current date. Okay, so that is what we're going to do. If there is a match, then add the delivery on top and put in today's date. The last thing we need to do if there is a match is exit the loop, because the job will be done. And we exit the loop by saying keep searching equals false. So our do loop is to do until it equals false. It was initially set with the value of true. So if we have found it, do your actions, change that to false. So as we loop back around, it then will not perform any more actions. So that is us searching for the ID and adding in the delivery and today's date. So now we're on to our next job, which is that if you haven't found it, enter it as a new product. So what I'm going to do is I'm going to put this in as a else if statement. If you've not found it, are there still more inventory items to look for? So I'm going to say else if cells row num, comma 1, dot value equals empty then. So else if is the cell empty? Because if it is, we must be at the bottom of the list. So if that's the case, what I'm going to do is I'm going to take a copy of these previous lines because I will need them, but I'm going to need to add some more to them as well. I'm going to create a bit of room for that. Now, first of all, with these, we need to keep search equals false because we need to exit the loop after adding the product. It's no good it continuing to look even after putting in a new product. There's no more to do. We need to put in today's date, and we also need to put the delivery in. What we don't need to do is add it on top of any existing value. So we don't need these lines here. So we can get rid of those. They're not really doing any harm because if the row is empty, then the value is 0 to start with, but they're not necessary. So I'll remove them, and what I will do is add in these lines. I'm going to add in 1 and 2. We need to add in the information to the first and second columns because it's a brand new item. The first one will be item ID. The second one will be assigning the product name. So in Go as a new product. Okay. And exit the loop. That is our new product entered. Now, it's not been put as a task here, but if you haven't found it and you're not at the bottom, the plan is to keep looking. So in a else statement, I'm going to put that row num equals row num plus 1. So we're going to add another row number on top so that as it loops round, we'll be looking at the next inventory item. And that is our loop done. So the next jobs are to clear the cells on the other sheet and to display a message to the user. So let's clear the cells first. I'm going to switch back to the update sheet. Activate the update sheet. I'm going to select cell A2 because it's probably a good idea that we position the user in that cell as a kind of logical kind of ending point of our macro. And I'm going to clear the contents of range A2 to C2 dot clear contents. So let's switch back to the update sheet so we can remind ourselves what's going on there. Range A2 to C2 are where the item is going to be appearing, and we're going to clear their contents once we've added it in as a new item or whatever we had to do. So our last remaining job, if I can come back up to these comments, is to display a message to the user to say that the job has been done. So I'm going to put an MSG box to say that the inventory sheet has been updated. So that message is just to put the user at ease, because when they run this macro, they're not going to see this stuff happen. So it puts them at ease that, you know, the inventory sheet has been updated. They don't have to check their work or anything. And that is the last task of this coding done. So we should have a macro that is capable of achieving that objective. So the plan here in this practical was to give you something to have a go at, or if you just wanted to watch the video rather than attempt it yourself initially, to see a more practical example of it. That's trying to combine a lot of the topics we've covered so far. Some of the difficulty of training VBA sometimes is that initially when you start talking about the concept of variables and loops, it's hard to get going with a great example until you've got all these concepts out of the way. So we can really start looking at some more sexy examples now, and some real true sense business examples. So we really begin to start putting these together: variables, if statements, cell references, VBA functions like date and message box. They're all coming to the forefront now in a proper example. Right, let's come out of this editor. I'm going to maximize this window, and I'm going to insert a button, or a shape to be precise, on my sheet here that's going to update inventory. And I'll leave it as that for now. I won't bother formatting it. I'll tell you what we'll do. I will make it bigger. I want to see the words. Right, it's a bit of a rubbish looking button, but that'll do. And I'm going to right click and assign our inventory update macro, so that, fingers crossed, let's double check, oranges has a current value of 78. Back onto update. Let's hit our button, and we get a message saying the inventory sheet was updated and the cells are cleared. Let's click OK and check it out. 78 was it? 128 now, and today's date, which is the 19th of February 2014, has been added for oranges. Okay, well, let's check out another one. Let's go for 1008. That ID is not on the inventory sheet. Let's pick a fruit item that's not there. I'm going to go for mangoes. Let's spell mangoes. You got an E or no E? I'm going to say E. I'm not sure. Delivery. There's been 100 mangoes delivered. Who doesn't like a mango? So let's just prove that 1008 even is not there. Mangoes are not there. Let's click my button. Inventory sheet updated. Let's have a look. A new item for mangoes. So it was able to unsuccessfully find it, but then add it in as a new entry. Now, not a bad idea as you go through this initially, if you're giving this a go yourself, that like all the other codes we've been doing so far on this course, we step through it. So if I did put one in, I can't remember what 1004 is, it's lemons, then it's not a bad idea that we, let's have 10 of them, that we F8 to step through our code. Now it's good to give it a check first of all. I can have my locals window available to track what's going on here and see what's happening. Row number gets 3, selects that sheet, goes into the loop and starts checking. Realises that's not a match, but not at the bottom, so we add one on top. Row number at the bottom is row number 4. Back round we go. Are you a match? This time you are. So in you go. Add it on top. You can see it in the background. Happen to hear that just went to 34. 12th of February is about to say the 19th. Boom. False. I can see, keep searching, move to false down in my locals window. Oh, this is exciting. Back round we go. No more looping because it does equal false. Move to update, move to A2, clear the contents, display a message box. F8 is awesome for figuring out why your macro's not working, or understanding others if you're going to be working with other people's macros. It really is useful for troubleshooting, and we'll look a bit more at troubleshooting later. I hope you find that useful. Please, I say, give it a go yourself. Maybe spend a bit of time looking if you can improve that. Think about adding more stuff to it. This is where our VBA skills really are going to take on kind of more levels. Hello and welcome to this lesson where we are going to start to look at counter loops. And more specifically, we're going to look at a loop called the for next loop. Now this for next loop is used when you have a predetermined number of times to loop, to repeat them set of actions. So we looked at the conditional loops in the last few lessons, where the exit point of the loop is some kind of condition, so you don't know and you're constantly trying to calculate it. In this example, we do know, or we've kind of figured it out, or Excel knows. And for this example, oh, my apologies. For this example, we want to look at deleting the blank rows from this list. So I can't remember how many I've put in. I've put in about 7 or 8 blank rows as an example in this list that we want to remove. So what we're planning on doing is we're going to run a count on column A, account A, as a way of storing how many rows in this list are non-blank, how many have got something in them. We're going to store them in a variable, and then we're going to use a for next loop to loop through that number of times. Now once I've done the count, I know how many times it needs to run, or the variable does, maybe I don't, and we can get our macro to run that predetermined number of times. So let's switch back to the editor, and I've just written a few comments like in the previous lesson as to what our plan is to kind of track what we're going to do. And the first thing to note here is to use variables to store the row number. So as we move through looking for blanks and removing them, I need to keep track of what row we're in at any given point. I'm planning to use an object called rows, as opposed to the likes of active cell and offset again. And I've got another variable for total rows, which is going to store that count A that I've just been talking about. As I say, we'll use a for next loop to loop through each record. We need to check if the row is blank. What I want to do is make sure the whole row is blank, not just a cell. I need to have a look at the row, so I'm going to use a count A again. I'm going to count the row. So if you come back with 0, if you didn't count anything, it must be blank. Now store the count in a variable, and then check if it's 0 and delete it if it is. My plan is to count how many I'm deleting. So a bit like your find and replace feature, or the remove duplicates feature of Excel. You may have used these before, but they always tell you at the end how many they've deleted. Or when you do a find and replace, it always come back and says, I have made 36 occurrences, or however it phrases it, I can't remember, but it tells you it's replaced some. We'll do a similar thing. I want to display a message to the user telling them how many we've deleted. So that's the plan. Okay, first thing, variables. Let's put them at the top. 2 variables here, one for the row number, one for total rows. So dim. Now for row number, I thought I'd call it R, and I thought I'd store it as long. I believe there are 92 in this list, I think. In reality, I would not know this. Excel's got over 1 million rows to potentially be used. Better put it as long. Just a reminder, you can call these whatever you want. R, I've obviously just used the first letter of row there, just to indicate for me. Very common for people to call them, row num, counter, or I, short for integer and stuff like that. Okay, next one, I'm going to call total rows. Oop. Certainly need some practice from my typing. Total rows, long again, has to be the same, wouldn't it? And as I look down these comments, I can see I've got another variable here where, when I'm ensuring if it's a blank row or not, I want to use a variable for that. So let's declare a variable for that, which I'll call isBlank as, so I'll go here, let's say integer. I could go for byte there. How many columns wide is it really going to be? But I'll play it safe with an integer. And then last of all, there's one more variable. Where are you? Yes, it's how many we've deleted. Number of rows deleted. That was my other variable I wanted. So we're going to say dim number deleted as, let's say integer. How many blanks could there be? Okay, so we've got 4 variables declared that in my initial planning I have identified. We can always come back and add more if we realise that we've maybe missed one out. And I'm going to take that one off our comments because job done. Achieved that. Okay, so next up we need to count how many rows we've got. Now if I want to use a for next loop to loop through to that number, I need to know where that number is. So I'm going to put total rows equals, and then our plan was to use a count A function to count how many rows there are, which I'm going to need to put application.countA. So hopefully you've done a count A function in Excel before. Counts all non-blank cells, really useful function. In VBA we'll need to access it through the application object. But just like any function, we'll have some opening brackets. I'll need to tell it what to count. And we're in VBA, so I'll probably use the range object, but I could use the columns object. There are other ways. I'm just going to tell it to count the whole of column A. Heavy reliance on column A here. You know, depending on your list, whether that's good enough. I'm relying on it as that is the name of a person in this pretend list. Let me show up the list briefly. We're going to have without a name. So maybe when entering somebody's unsure of the city at the point of entry, but she's not going to be unsure of the name. How could you put a new joiner in without a name? Okay, done. We know how many rows. Now let's get our for next loop going, which is what this lesson's all about. So these 4 next loops, as I say, they run a predetermined number of times. So either us or Excel know how many times to run it, and we want to access that knowledge. We don't need a condition to exit. We have no idea. The structure of them is to put 4, and in my case I'm going to say r equals 1. So you might have noticed that I didn't initialize r in the initial near the top of our macro, which we normally do. It gets initialized within the for next loop. For r equals 1, 2, and you know, there may be scenarios where you can just say like for 6. You know, repeat this action 6 times, or maybe it's 12 months in the year. You know, for r equals 1 to 12. You know, and at the bottom you'd put next, and that's the structure of your for next loop. So you can run it that predetermined number of times. It may just be as simple as telling it how many times to run, and it will repeat them actions that many times. In our case, it kind of is that simple, but instead of typing 12, I need to put total rows. Yes, we've got a variable, so we've actually figured it out first, and then supplied it for a for next loop to run that many times. So in this example, that should be 1 to 92, because total rows would have figured out as 92 rows. In our next lesson, we're going to be looking at a for next loop to loop through collections, which is another really popular use of a for next loop. So I'll leave that for the next video, but just to set a teaser there for other stuff these loops can do. Now the word next at the end, just like for do loops, put the word loop. You might see people put next r. No, it's not necessary for me to do that, but sometimes it can help, especially if you're nesting loops, which is also a topic for a later video. It will help you track what that next is for, what loop is that closing. It may be more descriptive if you put next r. But it's not necessary to do that, and you saw it was happy for me without it. Now it's there, I think I'll leave it in there. Let's get myself a bit of space and some indentation. Maybe scroll down this a bit. Ready? Okay, so within this loop, so let's say we're in row 1 at the moment because r equals 1. What do we need to do? Like, first thing I want to do is I want to check and see, like, are you empty? So I'm going to put is blank, which is the variable I decided to use to count what's in the row and store that information in. So equals application.countA. But this time what we'll be counting, so I'm going to count rows, and when it asks me for what row to check, I'm going to put r. closing bracket for rows, closing bracket for count A. So what that's going to do is it's going to count everything that's in the row with their index number. Initially row 1, but that will increment each time because the next R. Look at the second row, count what's in it, store it, next row. So it's always going to store how much is in that row. Right, let's remove some of these. For next loop is in. Sure it's blank. Okay, we haven't deleted it yet. So, count what's in there, store it in is blank. Now we've got the information, plan is to test it. So we're going to say if is blank equals 0, then if is blank equals 0, then there's clearly nothing in that row. Let's put my end if in, good practice. If is blank equals 0, then. So then, if that's the case, what we need to do is delete that row. So I'm going to put rows are dot delete. If they equal 0, delete the row. Rows are dot delete. Ensure the row is blank. Store that information in the variable. Delete it. Done. Okay. Another plan is to count how many rows we're deleting. Store it in a variable. We have a variable, number deleted. Now that we've deleted one, we need to put number deleted equals number deleted plus 1. So increment that number. Now we've deleted one, add it on top. And that will be that. It's only going to do it if it's deleted. It will then move to the next row in question. So hopefully this will do our job. The last bit here is to put a message box for number deleted. So underneath all that, I'm going to put MSG box. Our message is going to be number deleted. And I'm going to concatenate a message on the end. Rows were deleted. Okay. The number deleted and rows were deleted. So that would end up saying like 8 rows were deleted. Or whatever it may be. I think it's 7 or 8, something like that. So this is just an example of a simple little macro, little project that's going to go through and delete kind of single occurrences of blank rows within our list. We've tried to recap on some topics so far, like concatenation of kind of text within a message box here. But the main topic, of course, here is our for next loop. And if I was now to kind of restore that window, and if I click inside this procedure and look to step through it so we can see it in action, got my locals window at the bottom tracking our variables. As I move through, I can see that will run and count 92 rows. So now as we see here, it's doing for r equals 1 to 92. That predetermined number of times. It will go inside because it's on 1 at the moment. Check if it's blank. It's not. It's got 4 things in that top header row, that row 1. So it will skip that bit and go to next R. So R goes to 2. Obviously that's not blank either, so it will move through, go into 3, go into 5, go into 6, looping back round to 7, count it, count is 0. Row 7's got nothing in. If it's got nothing, move inside, delete the row, add one on top for number deleted, and move to the next R. So that is a simple little for next loop, looping through a repetitive number of times. I'm going to hit my play button to finish that off. 7 rows were deleted. I know it was 7 or 8, one of them. So that is our for next loop. We're going to see another example one in the next lesson, but a counter loop, as we commonly call it. Hello and welcome to this lesson on using a for next loop to loop through a collection. So what we're looking at doing is we want to apply worksheet protection to every worksheet within this book. And there are 3 sheets within this book, named after pretend stores for our business. And we're imagining that we get this received from a client, or just before we send it to a client, and we want to protect all the sheets. I want to do that quickly. There's 3 in this book. Sometimes, depending on what we're sending them, there might be 5, there might be 12, there might be 2, there might be 20. So we don't know. Good thing is, Excel does. It stores this information in what's called a collection. So Excel knows how many cells are in the range you selected, how many pivot tables there are, how many charts there are, how many workbooks you've got open. There are, a number of collections, and it's a really, really useful loop to get to grips with. We're going to use a counter loop, a for next loop, to move through that collection until the end, till it runs out of how many sheets there are, that predetermined number of times. So switching to the editor, I've just set it up with a new module and procedure here, protect all sheets. And the first thing we're going to do is declare a variable, which I'm going to call I and store as byte. So we're going to use this variable to store the index number of the sheet. So in this example, going from sheet 1 to sheet 3, but however many there are. Very common to see I used as some kind of increment or like an integer to count through. Byte, no more than 255 sheets. Okay, for next loop we're going for. So I'm going to say for I, my variable, equals 1, start from number 1. There's nothing stopping you in some of these loops saying start from number 2, start from number 3. It doesn't have to be 1. It just so happens in the previous video in here, that's what we've wanted. For I equals 1, 2. Now I need to say how many there are. I could do 3, but I want this to work in other scenarios too. So I'm going to say worksheets, the name of the collection. So we could have workbooks and examples like that. Say worksheets, the collection. Dot count. So what it's going to do is count. You see that's a property. It's a property of, I believe, all collections. It's going to plural versions. So we've got things like active sheet, then we've got worksheets. So the count property, it knows how many sheets there are. I'm then going to put next. As mentioned in the previous video, I could put next I, but that's not necessary. In the previous video, I'll put R in there, so I think I'll leave it blank this time, just to demonstrate that it's not necessary. Although it's not a bad practice to use. So as easy as that, I have a loop now for all the sheets within this book. So that's going to do its thing. Now what I need to do are the actions that I want to repeat. And I could write, loads of statements in here. For this demonstration, it's just going to be a quick and easy one. I just want to protect the sheets. I'm not going to worry about a password or anything like that. Just a simple turning it read only. So I'm going to say worksheets, opening bracket. So not our first time using worksheets in this course. That will prompt us for the index number of the sheet. So I'm going to tell it to use index number I. Dot protect. So I'm looking at protecting each worksheet. So we'll start from worksheet 1, protect the first one. Next sheet, protect the second one. Next sheet, protect the third one. Next, oh, there's no more sheets. End. So much smaller macro this time to get the feeling of going through collections. And if I was to, I might as well just run that actually. If I demonstrate the behind the scenes that everything's available for me on this London sheet. If I went to Bristol, it's all available for me. Manchester, it's all available. The review tab, it's not protected. Let's give this a go. Let's pop into here and let's go straight ahead and play it, shall we? Done. I can see it all ghost out at the background there. Hit review. That's protected. That's the Manchester sheet. Bristol, protected. London, protected. So all three sheets are protected. You know, I could quickly knock up another procedure to unprotect them. It would just be a case of, you know, copying this code maybe and changing that to unprotect. You've got a nice fast way of protecting all the sheets in a file and also unprotecting all the sheets in a file. An otherwise tedious process. So another for next loop there. In the next video we're going to be looking at the for each next loop to start looking at using references to objects within our loops. Hello and welcome to a lesson on the last of the three main types of loop in VBA, which is our collection loop. And we'll be using a type of loop known as for each next. So we actually looked at looping through a collection using a counter loop in the previous video, protecting sheets. Now we're going to look at looping through a collection using object variables. So we can create these variables as a way of referencing an object easily, such as within a loop. And for our main demonstration in this lesson, what I'm looking at doing is I've got 3 cells with some text in, so my favourite TV characters here, and what I'm looking at doing is converting all the text from a user selection to uppercase. So this is going to be a demonstration of looping through a collection. The collection will be the user selection, so whether I select the whole column or a single cell or a range of cells, we can loop and perform an action on every cell within that selection. As you can imagine, one of the most popular, also one of the common things you're going to have to do in VBA is perform an action to every cell within a user selection. Just think for a moment about all the things you do in Excel, selecting cells and converting to currency or turning them bold. Very, very common action. So we're going to use this convert set to uppercase, something that Excel doesn't handle very easily by its normal nature. So let's switch to our editor and let's get into the right module. So I want this book 1. I've just got a new workbook. I won't have a file to download in this example. And I've just started up a quick sub procedure called convert to upper. And the first thing I want to do is declare a variable, which I'm going to call RNG, as range. So I've got an object variable which is going to act as a reference to a range, which you'll very commonly see called RNG or just R. It's quite common things people generally call them. You can call them whatever you want. And then we're going to start up our loop, which I said is called a for each next loop. So we're going to say for each RNG in, and then we're going to give the name of the collection, which in this case is selection. Now if I remember rightly, we saw selection and it was on a sheet that you could look at in a previous lesson when we looked at referencing cells, sheets and books in different ways. Mega thing to know that just the word selection is a collection of all the cells that the user has selected. So at the moment, in the background for me, just D8. But the brilliance of that is it will work on any given user selection. Excel knows. RNG is just a reference I've created to be able to reference a range, because I won't know the name of the individual cell, so I could just say RNG and that is it. I'll need the word next, as we do in a for each next. As we do as a for next. This one's for each, where the idea is that this might be an easier way of looping through a collection as opposed to the previous counter. So there's nearly always more than one way, and you may not agree. But the benefit here is that we can reference a cell using a simple word like that. We could have even put a selection in the variable and use that as well. I mean, that's quite easy on its own, but we could have created our own name for it. So it makes referencing objects a lot easier than maybe using a counter loop with like the cells object or the range object or something like this, or the name of a sheet. This kind of idea. Now to convert it to uppercase, I can just say RNG equals, oops, where's my equals gone? Let's try that again. Here we go. And I'm going to use a function called uCase, which will convert to uppercase. It's all in VBA functions. Opening bracket, that will prompt me for the string to convert to uppercase. I will say RNG closing bracket. And as easy as that, we should have a loop that will loop through our selection, converting each range. So for example, if I select them 3 cells in the background there, just bring my editor back, and if I do F8 to loop through this, now we're not going to see the cells move because I'm not actually selecting them. But if we keep our eye on Mickey Mouse in cell C3, as we move in the loop, you can see the locals window storing information about the RNG object there. It will convert it to uppercase. Bounce to any other cells in there, and we're still in it. It knows there's 3. Bounce back. Last one. Bounce back, and it's out. There was only 3 cells in the selection. RNG resets itself to nothing I can see at the bottom there. So that is it. We can loop through a selection and convert cells to uppercase. So whatever that selection may be, let's quickly tap in hello and goodbye. And I'll just give it one quick other demonstration. Let's get out of that cell. Let's reset that and loop again. Whoops, let's select a cell first. Just reset that. Select a range. Back into the editor. Go, go, go. Uppercasing it all. A for each next loop. Now before we come out of this lesson, that's our primary example here, but I wanted to just open up the module for protect all sheets that we saw on the previous lesson. I'm just going to switch to that file as well. So here we are, this was the file. And we're going to use a collection loop, one in for each next loops, to protect all the sheets of this book. Something that we did in the previous lesson in a slightly different way. So this time, we'll declare a variable, which I'm going to call SHT, but you can call as you wish. And that is a data type of worksheet. So it's the object variable known as worksheet. And then we can use our for each next loop. And I can say for each SHT, because that's going to act as the worksheet, in worksheets. So worksheets is the name of the collection that I want to loop through. Excel knows there's 3 sheets in that. Next. So in the middle, I can just put SHT dot protect, or whatever it is I want to do. And I may have multiple things, which means this variable makes it easier for me. So another way of looping through all the sheets in the book, you may find it easier because it might read better for each sheet within worksheets. Kind of rolls off the tongue. But yes, it's a kind of alternative to a counter loop when running through collections. Brilliant for looping, doing things for every sheet, every chart, every cell within a range, every workbook, for example. So if I was to play that loop, or play that procedure, and look in my background, I can see that all the sheets, no surprise, are protected. So we've achieved that objective using a different loop. So that is the last of our 3 main types of loop, for each next loop. Next video we're going to look at nesting loops, just to kind of take it up a notch. Hello and welcome to this lesson where we start to look at nested loops. So the concept of putting one loop within another. And for this example, we're going to revisit the inventory sheet where we were looking at our conditional loops or our do loops earlier in this section of the course. And what we're going to do here is we've got our inventory sheet from earlier, but this time on the update sheet, instead of the one update that we've been having earlier, we now have a list of multiple updates. In our example here, 3. So what we want to do is we want to perform the loop for bananas. And just to remind ourselves, the plan is to look for 1009 down this list of inventory. In this example, we will not find bananas, so we'll add it in as a new entry. Then we want it to pop back to here and loop to the next one. Look for 1004, look for that, find lemons, add it on top, today's date, come back here, look for the next one until it runs out. So we're going to have to loop on the inventory sheet whilst we're looking for it. But we also need to loop on this, we need an exterior loop to loop on the updates to happen. So let's pop back to the editor. So this is the code we've got in the file to download, or from previously in that lesson. Where at the moment the item ID and that is accepting the range object. And we've got our do until and a boolean variable loop for looking through the inventory sheet. So what we're going to look at doing is adding an exterior loop for the other update sheet. And I'm going to use the cells object like we have on the current loop. So our first plan is to add a variable name, which I'm going to call I, and store as integer. Working on the idea that I'm not going to have more than 32,000 products to update. So I'm going to use the I, typically short for integer or incrementer. It's a common thing to put as some kind of counter. And then I'm going to store that in my initialization area. I'm going to say that I equals 2. Where am I going? I equals 2. Give an initial assignment. It equals 2 because, just to remind ourselves, if I pop back to the sheet, the first record in the update will be the second row. And then I'm going to start to put a loop together. So I'm going to put a do until loop. I'm going to use the cells object I, 1 dot value equals empty. So I know that somebody's going to be on the update sheet when they run this, because that's where the button is. I'm saying do until the cells, so currently A2 there, first column, and I equals 2, so second row, do until you run out of updates. And I'm going to scroll down to the bottom of our loop, and I'm going to put the word loop after that one there for the exterior loop. So I might actually add a comment after that with an apostrophe there, and say that this is the exterior loop for the update sheet. So if I'm looking at these loops, I know what one's what, and there's only 2 here, but it could potentially be more. Okay, so now we've got this in play, I'm going to revisit these range objects that we had. What I'm going to do is I'm going to move some of that stuff to inside our loop. So these, and I keep searching equals true, and that, this bunch of stuff is going to go within our exterior loop. Because every time we go to an update, I'm going to have to update the item, product name and delivery with the next one. Keep searching will need to be reset to true before, oops, didn't mean to scroll there, before it re-enters this interior loop, and the row number will need to be set back to 3 so that when it goes back to look in the inventory sheet, for example, the second one will be lemons in this case, after adding bananas, it will be returning to 3 to start again at the top of the inventory sheet. So I'm just going to simply cut and paste these lines so that they occur as the first things within that loop. And I'm going to change the range object, because saying A2 is not good enough anymore, to that I, 1 cells object, and for the others the relevant column, I, 2, and for this one will be cells I, 3. So instead of a range object, as we loop through, and this I will be incremented, and we've still got stuff to look at, it's going to grab the ID product name delivery, reset, keep searching, go again from number 3, onto the inventory sheet, let's go. Do it until it's false. Come back round next one. Talking about next one, this will need to be incremented. Start from 2, do your thing. Once we've found it and done what needs to be done, and that loop is ended, before we loop back round, I equals I plus 1. Increment the row number for when we come back round, we can check that that has got something in it, or if it's empty, don't do any more. Notice that there's no reference to the worksheet in this test. So after the incrementer, now we've moved to the inventory sheet there. When we do this test, we'll have to make sure we're back on the other one. So after the incrementer, I'm going to say worksheets, update, dot activate to move ourselves back to the update sheet. Now this is beginning to look like the part. I think the only thing we're missing now is an area at the bottom of this sheet. Oh, we don't need this anymore, this reference to update, because I know it's going to move itself back there. So I don't need that line. Let's delete, whoops, let's keep the A2, but let's delete that line. A2's okay, that will always be the first one. This, all of a sudden, is not. Clear the contents of A2 to C2. Now I can't guarantee how many rows there will be to update. I'm going to need our loop to figure that out itself. So this sounds like the use of another variable. So at the top, I'm going to create a variable, which I'm going to call num new stock. So how many new stock items are there that we're adding? So I'm going to store as an integer. And to initialize this, which I think we'll do after that incrementer, I'm going to say new num stock equals, I'm going to use the count A function here to count the contents of column A. So count how much information there is in column A, including the heading, because the way I'm going to do this is capture the last row number. So I call it new num stock. It's kind of like new num stock plus heading. But we know what we mean by how many stock. Like where does the list end sort of scenario. Count the contents of column A, that will give you your answer. So for example, on the update sheet, count column A, oh there's 4, that will be the last row. Let's pop back to the editor, and now we've got that information in new num stock. No need to reference a sheet because somebody will be clicking the button on that sheet. Down here, I'm going to remove this 2 from the end of that range, and after the speech marks, I'm going to concatenate new num stock onto it. So it's going to be A2 to C blah. In a first instance, it will be C4, but that will figure itself out because of our variable. So this, I believe, is it. I hope you've followed that through okay. We've looked at adding an exterior loop, a second loop. Let's give it a trial run. I'm going to restore my window a bit and bring in the locals window. I'm not sure if that's going to come in handy or not, but I've got a few variables now, so it might help reference. And I'm on this update sheet. So typically, I'd click that button. But let's step through it. It's F8. Variable not defined. Oh, put my variable names wrong. Look at that. Num new stock. New num stock. Let's click OK and change that round. That's a fantastic little reminder that as to our option explicit line and what that can do for us. I wonder if that means I've got it wrong down here as well. I have. It's num new stock. Let's delete that. Num new stock. It's a click away. Look at it liven up. It likes that. Alright, let's reset that, shall we, and try again. Oh, here we go. Locals window at the bottom, populated with variables. In we go. Count it. So we look at the locals window. 4 num new stocks there. In we go. Let's watch these item IDs. Boom, boom, boom. We've got 1009 bananas and 20. Search extrude. Number 3. Switch to the inventory sheet. Off it goes. And in we go looking. Now it's going to have no success looking for this first one. Bananas is not there. So I'm just going to quickly keep looping through. And we can see the row number in the background changing. It's on row 7 at the moment. So it's checking the strawberries one. So 2 more. Off we go. Back round, what we're on now? We're on 9. This is good. So it will go in. It's not a match. It is blank. In you go. And we can see in the background now on this sheet, bananas is going in. Boom, 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 boom. Round we go. End if loop. Foul. I equals I plus 1. So now we're on to row 3 on the other sheet. Move back to the other sheet. Exterior loop. Do until you're blank. That is not blank, so in it goes. And we can see now it's gone to these variables 1004 lemons 50. Reset to true. Reset to number 3. Back to the other sheet. Let's go again. No match. Second time going is a match. And I can see 34 went to 84 there in the background. 19th of Feb is about to get some treatment. There we go. Loop back round to the next one. So we can see our exterior loop seems to be working fine here, as it looping within one loop, coming back and working with the other loop afterwards. Now if I can shoot through this, I should at some point get to the end. I could hit play, to be honest, but trying to do it properly. I'm in row 10 now, so it is checking the last one. Here we go, adds blackberries in there. Goes to the second loop, misses out, clears the contents. See, they all go and updated. Our exterior loop, absolutely fantastic. Now, just looking at that, there's absolutely nothing wrong with this. It worked an absolute dream. I'm just thinking that do until loop, although it's absolutely fine to say to look for blank, we do now have num new stock recording information. So what I might do is change that to a do while, and I might say do while I is less than and equal to num new stock, because now I know how many rows there are. It's recorded there. There was 4 a minute ago. This saying do while you in that range. Now, there's nothing wrong with how it is. I'm just trying to incorporate information I have like this, trying to keep some uniform to it. And so I hope you followed that through okay. So we get to our more intense examples here. I want to make sure we don't lose ourselves. You know, this kind of stuff just takes practice. You know, we've got examples here that you can download these files and you can keep testing them out and get used to it. But a lot of the key really is to have a play, try changing it round, try and create your own scenarios and complicate them and see how you can get around them with the skills we're doing on this course. These loops, these variables, these conditional statements like your if then else and your select case. Hello and welcome to this lesson where we look at a few simple lines of code that we can add to our procedures to make them execute faster, but also to prevent some interruption that can happen depending on what your procedures are doing. So I've just got open the a macro that we've been using a bit on this course, this inventory list. Any file will do for this, so I'm not planning on providing this for download. Any file will do, and this file was not really big enough to justify some of the things we're going to chat about anyhow. But I'm going to switch to the code view, and these lines of code I'm mentioning, I'm just going to be near the top of this procedure, so I'm using this as a kind of guinea pig for this. Typical place they'd go is probably just after the variable initializations. It depends what they're doing, depends how you're initializing. There's no hard or fast rule. But the first one is application.screenUpdating. Now this is the most common one, the most popular one of these lines of code we're going to mention. What we can do is we can turn off screen updating by saying equals false. And this will prevent that flickering on screen. So if you've got procedures similar to this one that are moving between sheets and are looking through cells on a sheet, we can turn off the screen updating. That will prevent that flickering. It means that during the procedure, Excel will not have to update the screen, which ensures that your procedure executes much, much faster. It also stops that flickering, which can, at a minimum cause a headache, and at most could potentially be dangerous, that kind of flickering of your screen. So we literally just turn that off, and then probably copy that line, or not properly, we should do this, copy that line, move to the bottom of a procedure, and maybe just before my message box, just before my message box, but after actions like select, because that's the kind of screen updating we don't need to see. I don't need to see it select a cell, just select it. And I'm going to change it back to true to turn screen updating back on. So this is a typical thing to do, to switch screen updating off at the near the top, and to turn it back on at the bottom. This will drastically improve the speed of your macro. I mean, it improves it a lot. It all depends on the size of your procedure and what it's doing as to whether you're going to notice this different or not, but it does make a difference. And it stops that flickering. Now, because this is on the application object, I don't really even need to type application. You probably find that I do a lot on my code. It's partly habit, but I like nice readable code. Once again, there's no hard or fast rule. You'll talk to one person and say, "Oh, I should put application," like over there as well. You talk to somebody else and go, "Why are you bothering? You don't need to. Screen updating, it's shorter code." Blah blah blah. So I'm going to add mine back in because I'm a fan. But it's not necessary when on the application layer. So on the Excel layer. Okay, let's look at another one. So another one is application.displayAlerts. Now what this will do is we can switch this one to false, and this will stop the interruptions, some interference. Display alerts will prevent certain alerts that, if not switched off, will interfere with your code. So whilst the procedure is running, the procedure will have to pause to display that alert to you, and will not continue until you answer that alert. Once again, this will typically be copied to the bottom, that line, and pasted below what I've got, and false switch to true. Very important, this one. You want your display alerts back on. Now, a typical example of this happening will be the deletion of a sheet. Now, I've just added this sheet in solely for this purpose. If I go to delete that worksheet, I get that message. That is an alert. So if your procedure was to delete sheets, your procedure would have to pause to display that message and use a click delete before it will continue, unless you have switched display alerts off. And if your procedure's deleting sheets, there's a reason for that. You don't need that message. You know you're doing it. That's why you wrote that code. So you probably is something to switch off. I'm going to cancel that. Not that I really need that sheet. I should mention, because I'm adding more things to the application layer now, I'm trying to scratch my head and think how much we've spoke about this on this course, or if we have. There's a very basic structure called the with statement that, as I'm a fan of using the word application, I could still abbreviate this by saying with application, and then I could indent these lines, get rid of application there, indent that, oops, end with. So I can put it in a little structure like that for readability. I'm repeating the word application. I don't need that. With application, dot this, dot that, dot this, dot that, end with. It makes your code more readable. And I'll do the same down below on the other example, but I can't bother to do that now. I'll just be repeating myself, really. Okay, let's add one more. Let's stick it into that with structure that I have. The last line to display for you, to mention, that can improve the speed of your execution is dot calculation. Dot calculation. This one is not set to true or false. This one is equal to, and to switch calculations off, we would say calculation manual. So every time your procedure will do something, like change a value or something like that, calculations on your screen will calculate. So if you have a lot on there, if you've got some VLOOKUPs and whatnot, some if functions and all this jazz going on, this will also add calculation time and really slow down your macro. So we can set them to manual so that during the I'm going to copy that now. During the procedure, they will not have to calculate every time something has changed. You can say, right, just calculate when the macro's over. I might not. Might is the word. I can't speak for your procedures. I haven't seen them. I don't know what they do. But they might not be necessary during the procedure unless they're relying on some of their values. I've just copied that while I'm talking, changing them to true, and I'd need to set this to automatic to turn it back on. Which I think is that. Let me backtrack. Let me just put that in. Equals, and it should come up for me. Yeah, it's just that. Yes, you may have covered this before. If I pop into Excel in its normal interface and go to formulas on the ribbon, we have these calculation options over here. So that's what I'm doing. Excel defaults to automatic unless you've dabbled with that in the past, or somebody else on your laptop has, for example. But during our code, we can switch that feature to manual, switch it to automatic before we come out. So you've also got the button there that you could manually change. But we can do that within code to speed up our procedures execution. So we've got two lines there that will make big differences to the speed. Another one to prevent interference. Certain alerts, probably the most popular one being the deleting sheet alert. But there are obviously others that will, when added to your code, improve their speed and their efficiency.